So the water level in Whanganui River bar is the best modeling by the sine graph. So we're going to use sine to create this model here. The depth reach, that's the max. And that's the time of the max. Sorry, that's the max, that's the time of the max. So it's 4:30 a.m. means 4 hours and a half. So 4.5 hours after midnight. And that is the minimum. And what time it starts, happens is 10 hours after midnight. Form the equation to model and then use it to find the interval. So we're gonna create our working station. So our working station, remember, max, center line, and mid. Okay, so that's the maximum, that's the center line, and that's the minimum. Now the values are 6.6 and the minimum is 2.1. Now the center line, or the center line, we calculated by 6.6 plus 2.1 divided by 2, and that's equal to just 4.35. Just the center line is the same as the vertical shift. I'm just going to write it here, vertical shift. Okay, now the next one is we're going to find the amplitude, which is another easier one. Max minus min 5, and it's equal to 2.25. And so that's your amplitude, the A variable in your equation. And to double check that you're working, so 6.6 minus the midline, 4.35, should give me the amplitude, which is 2.25. And if you do 2.1 minus 4.35, and give you the amplitude. So this one here is the amplitude, and this number here is the vertical shift. Now we need to find the period, so we need to go back and see when does the maximum and the minimum happen. So here you've got the maximum happens at 4.43. So the x-axis, it's hours after midnight. Okay, so that's 4.5. I actually mark. So it's 4.5, or you mark it here, it's up to you, the timing, and 10 a.m. So you can see I don't have, I didn't divide it into equal gaps or anything. It's just a sketch, okay? So it doesn't have to be accurate 100%, but it's just a sketch. So it doesn't have to be the gaps and everything is accurate. It's all estimates. So 2 points, so it's maximum at 4.3, so that's my max, and that's my min. So I've got this curve here. Sorry, don't like to draw the curve like this. So that's my min and that's my curve. So remember, we're moving from max to center line, then center line to min, so that's a half of the period. So we need to do 10 minus 4.5. That gives me 5.5. And that's half of the period. So that means the period equals 5.5 times 2, and that gives me 11. So that's the period. And the last one is the horizontal shift. Now, it's asking for sine graph, so that means we have to start, sine graph start midway and goes up. So you can do a negative sign in here, because you can see you've got the midway here. And that's a negative sign because it's a midway going down. So the sine graph, it's midway going up, increasing, midway and then increasing. So that's the sine graph. Because we have midway and decreasing, that means it's a reverse sign. So it's the negative. Horizontal shift. Sorry. Shift. Okay, so that's equal, so midway 4.5 half. So we need to find what's a quarter of a period, because we're moving one step. The graph starting at high, we want to start midway, so we need to know what is the time here. Okay, so we go do 5.5 divide by 2, and that give me 2.75. so the distance from here to here, it needs to be 2.75. So 4.5 plus 2.75, and that gives me 7.25. So that means the horizontal shift is 7.25. Now we write our equation. So the height equal amplitude is 2.25 sine 2 pi over the period, 2 pi over 11, open a bracket, time in hours minus 7.25, close the bracket, plus 4.35. And that gives me my sine graph. And now to find the equation, or find the time interval in hours that a boat requiring 3.7 meters has to cross the bar. So that means you are substituting, instead of the height is 3.7 equal 2.25 sine 2 pi over 11 minus 7.25, close bracket, plus 4.35. I'm gonna use general solution to find this. You don't have to, you can use Desmos to find it, but I'm gonna use general solution, and then I will put the Desmos along with it. Okay, so for general solution, remember, all we need is alpha. It's sine graph. Just gonna find out what is the equation. Okay, so the general solution, I'm just gonna write the equation here to remind you. It's in the formula sheet. So it's sine theta equal, sorry, it's not sine theta. Here, it is theta n pi plus -1 to the power of n alpha. Okay, so all we need to know what's alpha, what's theta. And remember, when we find cosine sine, it's always cosine to theta. Cosine to theta. That means this one here is our theta. And sine inverse to all the rest of the numbers around is our alpha. Okay, so I'm just gonna do that. So I'm gonna rearrange. So I have sine inverse. I'm just gonna put the number straight away. I've done it in the calculator. So it's 3.7 minus 4.35, and then you divide by 2.25. I'm just rearranging, and that's negative 2.89 equal the theta, which is 2 pi 11 open bracket t minus 7.25 close bracket, and yeah, that's it. Get to the next one. Okay, so that's what we're trying to find. Just gonna solve it in here. So that's sine inverse. Just gonna make sure my calculator in radians, because I'm using pi, and then I will just do sine inverse to that. I got negative 0.29 equal 2 pi 11 t minus 7.25. So that's the theta equal sine inverse. And now I'll substitute in the formula. So the formula, reminder, it's theta equal n pi plus -1 n alpha. So the theta is 2 pi over 11 open bracket t minus 7.25 equal n pi plus negative 1 n times alpha, which is negative 0.29. Okay, and now I have to rearrange. I don't want all of this, I just want t. So I'm gonna take the 11 to the other side and leave t on, rearranging all in one go, one step, but you can listen and follow it slowly. So that's the right hand side. All of that will be multiplied by 11, divide by 2 pi, and then a plus 7.25 at the end. Okay, once you get that answer. So now you can find your calculator. You can go to your graphic calculator and rewrite this equation in graphs. So when you write this, sorry, not in graphs, in tables. So when you write this equation in tables, you have to put 11, sorry, open a bracket, 11, open another bracket. Instead of n is x, and the x is the button under the alpha, and then pi plus, open a bracket, negative 1 all, a close bracket, all to the power of n. The n, remember, it's x, which is the under the alpha. There is an alpha red button in your graphic calculators, and then open a bracket, negative 0.29, close bracket, and close the bigger bracket. So there is and then divide by 2 pi, and then close the big bracket, and then do plus 7.25. Actually, you don't need to have a bracket after the 2 pi because as a division have a higher priority than addition anyway. So you can just make sure all the numerator is inside one big bracket. Okay, to make sure that all the numerator will be executed first, then you divide by 2 pi and then a plus 7.21. The steps, the set, you go to set and you can choose from negative 2 to whatever, 2 or 3, and then the step is 1, and just find the answers from there. Okay, so I'm just going to show you how you're going to write for n equals 0. So I will say Tn is equal to 0, and then I will say t equal 11, open a bracket, 0 times pi is just 0, negative 1 to the power of 0 is just, I'm actually going to write it down, plus negative 1 to the power of 0, oops, I don't need that bracket in here, and then open a bracket, negative 0.29, close bracket, and close that big bracket, 2 pi plus 7.25. So I'm just showing that I'm substituting, and then I can get this t, the answer here, from the calculator, or you can do it by hand. So 0 times pi is 0, plus anything to the power of 0 is just 1, so therefore it's negative 0.29 times 11, and then divide by 2 pi, get the answer, and then do plus 7.25, and you get the answer 6.74. Okay, and if you look into what 2 pi is, so you can see the value of 2 pi is 6.28, so it's more than 2 pi in here. Or you can say the time here is 6.74, which is 6 hours and 70.74. You can change the 0.74 times 60, change it to minutes, and that 44 minutes. So I can say 6 hours and 44 minutes. Okay, thank you.